Hello everyone, welcome to the part 2 of the surface tension video. I hope you all have watched the part 1 before watching this. So now let's continue with the next set of experiments.
Now we'll see another experiment which is also a very interesting one, which is the floating paperclip. What you all need to have for this is you need a beaker or mug. Any transparent container would work which can hold some water, some metal paper clips, Q-tips, paper and soap solution. You can also use tissue paper. Now let's see this experiment. So I have this beaker which is filled with water. Now first I'll place this paper clip inside it. It sinks. Why it sinks? Because its density is higher than that of water. So due to gravity it just settles down. Now what I'm going to do is I'll bring a paper clip which is kept on a tissue paper or any paper. You just let it allow the paper to wick fluid. Now as the paper absorbs fluid, now just slowly with the help of Q-tip, try to separate this paper from the paper clip. You have to carry out this step very slowly such that you don't disturb it very much. If you will use force while removing paper, the paper clip will settle down. So you have to do this step very gently. See, half of the paper is removed. And I am trying to remove the other part as well. Yeah, it is removed. So now we can see that paper clip is floating on the surface of water. Isn't it interesting? Earlier it sank, now it's floating. Well, this could be explained due to surface tension. But we'll just extend this experiment and see what happens if we place some fresh water in this. Will it sink or will it still float? Let's find out. Here I'm adding water. It's still floating. That's good. Now let's try the same thing with a soap solution. What happens if I add soap solution in this liquid? Here I'm adding soap solution and see what happens. Oh, it sinks. Why did this happen? Because detergent lowers the surface tension of water and therefore the paper clip sinks. Now we'll understand this. Why in the first place the paper clip was held by the water surface? Because water has very high surface tension. So as I explained earlier, the cohesive forces between the molecules is what causes surface tension. The stronger the cohesive forces, stronger will be the surface tension. Now where do these cohesive forces come from? As you would know, water means H2O. So it has one oxygen molecule and two hydrogen molecules. So due to the electronegativity of oxygen molecules, it has some negative charge on it. Let's say delta negative. And hydrogen has some positive charge on it, delta positive. So in this way, one water molecule can interact with another water molecule, that is hydrogen of this molecule is interacting with the oxygen of the other water molecule and forming a bond. Such bonding is called hydrogen bonding, which are quite strong bonds. And these lead to the strong cohesive forces between the water molecules. And this results in higher surface tension of the water. Now what you can try is, what would happen if instead of water I use milk and try to float paper clip on that? Will it still float or not? You can also try it with some juice or any other liquid. You can use oil and see what happens. That's for you to do at home. Let's see another experiment which is using black pepper and soap. So for this again you would need a tray or a plate, some water to fill it, black pepper powder, Q-tip and soap solution. We'll see how this experiment works. So I have a tray which is filled with water. You can also take a plate and fill it with water. Now I will sprinkle some black pepper on it. You'll see that black pepper floats on the surface of water because it is lighter than the water. See, black pepper is floating on the surface. Now it's floating. Now take some liquid Vim or a soap solution and just add it on the Q-tip. If you don't have a Q-tip, you can use a finger and place some soap solution on your fingertip. Now place this Q-tip with soap in this solution. See? Wow, the black pepper just moves away from the Q-tip. Isn't it magic? We'll find out. Why this happened? Because detergent lowers the surface tension. So a detergent molecule has two ends which enable it to break the surface tension of the water. The end of the detergent molecule, which can attach to oil or fat or grease, it repels water molecules, is the hydrophobic tail. This is the hydrocarbon chain which is hydrophobic. And the other end is hydrophilic, which loves to stay with water. Now this hydrophobic end, it attempts to move away from the water molecules and thus it pushes itself up to the surface. Now this weakens the hydrogen bonds holding the water molecules together at the surface, and this results in the breakage of surface tension of the water. So you can do a simple experiment at your home. Take a coin, or you can take aluminium foil, or you can take butter paper, anything you can take. Just place liquid water on top of it. You'll see that it bulges around, it forms a droplet. Now add some detergent or bring soap solution to it. It spreads, it flattens out. So when the surface tension is lower due to the addition of detergent, the water tends to spread out. So as the water flattens on the dish in the experiment which we have just seen, the pepper that is floating on top of the water is carried to the outer edge of the tray as if it was magic. It's not magic, it's actually surface tension. I hope you have understood the concept of surface tension with these three simple experiments. And that's all. Thank you so much.